Okay, I decide what characteristic equation I want. Okay, now I just asked the class, I said, okay, we're going to do lambda squared plus some multiple of lambda. What multiple of lambda do you want? Somebody said 1. Okay, lambda squared plus lambda. Then I just add some number over here such that 4 times this number, which would be 4ac, is bigger than the square of the coefficient of lambda. Well, coefficient of lambda here is 1. Our discriminant is going to be 1 minus 4 times this times this. I just want to make sure that's negative. So I did. Okay? So there it is. And this is a characteristic equation. Now this characteristic equation, if you think about it, to get lambda squared plus lambda, I better have a lambda here and a 1 plus lambda here, or a negative lambda and a negative 1 minus lambda in this case. That's going to give me lambda squared plus lambda, and that's the only place I'm going to be able to get a lambda squared plus lambda. So I don't have much choice if I want this to factor over the real numbers, over integers, and make it, make the eigenvalues manageable so they don't get too messy. That's what I get. Now, you learn to do this with non-messy eigenvalues. Well, you can do it with messy eigenvalues. You just got more arithmetic to do. It's no big deal. Okay, so you see that to get lambda squared plus lambda, this has got to be in my diagonal. How am I going to get this plus 5? Well, I'm going to be subtracting this diagonal, the product of this diagonal. So a negative 5 and a 1 here will give me plus 5. Now I could have the 1 here and the negative 5 here. Or I could make the 1 negative and the 5 positive, or I could reverse those. So I've got 4 possibilities for the numbers I put in here, which gives me 4 possibilities for my A matrix. Okay, what's my A matrix? Well, to get negative lambda, well, remember what I've got here is going to be whatever's in the A matrix minus lambda. To get minus lambda, this better be 0 then. And to get negative 1 minus lambda here, I better have a negative 1 here. And then again, I can have my 5 and 1 here and here, or I can put my 5 here and my 1 here, and one of them has to be plus and one of them has to be minus. So there are 4 possible ways that I could put my 1 and 5 in here with the right signs in the right order. Which means that my system is y1 prime equals negative 5 y2, y2 prime equals y1 minus y2. That's how I make up these problems. I'm going to write that into the computer. It's a pretty simple process. And just choose some random numbers and then fix things so that I've got a negative discriminant. And we got a factor where my discriminant comes out with either very simple fractions or integers, where my complex solution comes out with very simple fractions or integers. And then I write down the system and ask you to solve it. You can make up your own as easily as I can make it up.